Alright, 4.4 homework examples. In 4.4 we're dealing with probabilities, compound probabilities that involve the word and. So it means we're going to be combining these things together, two events simultaneously, and join together with the word and. Usually when we're doing with and, it's one thing after the other. One event follows the next. Alright, so this question says, with one method of procedure called acceptance sampling, a sample of items is randomly selected without replacement. It means we're going to pull them out and not put them back in, and the entire batch is accepted if every item in the sample is okay. Right? If all items in the sample are okay. Right? A company has just manufactured this many CDs, 285 of which are effective. Right? If 8 of these CDs are randomly selected for testing, what's the probability that the entire batch will be accepted? Okay, so you have to understand what's being asked here. For the entire batch to be accepted, how is it accepted? Right here it tells you the batch is accepted if every item in the sample is okay, meaning not defective. So the probability that all 8 CDs are not defective. That's what we're looking for here. That's the probability we're being asked to find. So for this to be not defective, the first one can't be defective, the second can't be defective, the third can't be defective, and on and on and on and on and on. Alright, now the other thing that's important is that we're sampling without replacement. So once something comes out, it doesn't go back in. Okay? Now, if there's 285 that are defective, the probability that the first one is not defective is the remaining, not the 285, but the 1796 minus the 285. Alright, so 1511 out of the 1796 are not defective. They're okay on the first try. That's the probability of getting one on the first try that's okay. Times, for the second try, this is going to have to go down. So we pulled one out, so it's 1510 that are not defective, and there's 1795 remaining. Alright, and then we just need to keep going down with this. Alright, until we got all the way down and 8 CDs accounted for. So if you look, I've got 1, 2, 3, 4, 5, 6, 7. Oops. I went down one more here. 1504. That last one should be 1504 over 1789. So I should have all 8 things on there. 1504 over 1789. So if I put all that in my calculator, which I've already got it in there, and hit enter, I get 0.250 roughly to 3 decimal places. So I've got that approximation in there. But what I wanted you to see, this is called the calculation, or if you're talking about a cumbersome calculation to do this procedure over and over and over again. If you got several different steps that you're going to do, and you're just taking down one from the top and bottom, and there is a very small difference between going down one of these from one to the next, meaning like if I look at 1511 divided by 1796, and the very next one would be 1510 divided by 1795. Right, there's really not much of a difference between these two as we go down. So what the shortcut for cumbersome calculation says, I can take this first value, this 1511 over 1796, and even though we're doing it without replacement, we're not putting these CDs back in there, we can estimate it by doing that, because I'm doing 8 multiplications, and it's not that far off. 0.25, this would round to 1, whereas this didn't round to 1. Okay, but this is technically how you would do it. You would back off because of the without replacement. You would be backing off 1 on the numerator and denominator as you go left to right. Alright, then the last example from this section, use the data in the following table. We have 174 pedestrian deaths, so all of these 4 numbers are going to sum to 174. Alright, if the two, we're going to pick 2 deaths at random without replacement, so we're not going to put the first one back in there. Find the probability that they both involved intoxicated drivers. So intoxicated drivers, that's this row. Okay, so far at the beginning there's 40 where the driver was intoxicated. So for them to both involve intoxicated drivers, it means the first has to and the second has to. So the probability the first involves an intoxicated driver is 40 out of 174, and the second one also involves intoxicated driver. So this first one I picked was intoxicated driver. I throw it out because I'm not replacing it, so it's not going back into the data set, so that means 39 remain. And then 174 was the total, but since we took one out, there's only 173 left. So that's our probability, and then we can multiply to get an approximation. So 40 divided by 174 times 39 divided by 173, so approximately 0.052. Now some of the questions that you see in this section will say, is this a rare event? Would this be rare to see that? And they want you to cut it off at 0.05. So 0.05, this is 0.052. This would not be considered rare according to our data set. Alright, now again, it's got that block right there. So I could have taken that block, done the same thing we did on the last video, copied it to my clipboard, and then bring it into Excel and paste it. Alright, and now I'm looking for the probability, back to this problem, I'm looking for the probability that they're both, the first and the second, involved intoxicated drivers. So again, I could look at Excel. These are the drivers intoxicated, add those together using the sum button. I got 40 and then just started the process. Alright, that's 40, that sums to 134. Down here I type equals sum, and then just click those two values separated by comma. Alright, so then I would write equals 40 out of 174, that was the first probability, and then times the second probability would be 1 less than this, so 39 divided by 173. Okay, and then I get the 0.0518 or 0.052 like we got last time. Alright, so you can throw that into Excel and get your data values. It's a lot more helpful, I think, with the conditional probabilities and the or probabilities like we saw in last section, and the conditionals we'll see in the next section, than maybe with these types of probabilities. But it still can be helpful and is there if you want to use it.